approximately 70% of the room of educators will not even attempt it. Not because it is difficult or they can't think about it, but somewhere or the other, there is this artificial thing which says that I am an English teacher, maths is not my subject.
So their ability to learn is so enormous. Are we giving enough food for them to digest things on their own? It is not filling a bucket. Teaching is not filling a bucket. It is lighting a lamp.
I know how to do a lot of, let's say, magic tricks using calculus, but I may not have understood the fundamental idea of why I am doing what I am doing, how I am doing.
This I see at all levels, including at the university level. I think the problem is the other side of the syllabus is the exam, right? And so long as we are driven to teach towards an exam, we have constraints about what we can teach or how we can teach it.
Right? You are not communicating only with words. You are communicating with words. Even if I am reading something, I must be able to read it with expression in my head. So which means that the inner vocalization has to be of a certain quality. If I am reading a science textbook, I need a certain kind of vocalization to be happening.
So you can see the peer level learning and throwing a challenge at them is one of the most important aspects which is missing.
There is, I think, a misguided notion that we all need to know all this, right? So I think we are just too obsessed in a way with teaching everything to everyone.
When we talk about can a 2-year-old or a 3-year-old deal with algebra, by all means you can deal with algebra. Namaste and Vanakkam to everybody. During the lunch break, in case you were paying attention, there was one question that a student asked about how do we inculcate inquiry-based thinking among students. If we look at the topic that we have with us today, I think that is one of the areas that we would end up addressing. Specifically, I'm extremely privileged to share the space with Dr. Natarajan and Dr. Mukund. Their academic credentials are stratospheric. Their experience is at the same level. The institutions that they have actually been a part of have nurtured some of the brightest minds in the globe. And so I'm hopeful that we will have a very inquiry-provoking discussion over the next 45 minutes to an hour. Just to give you a sense of, to make it more participative, we will be speaking for about 5 to 7 minutes, each of us, to give you a little bit of a background in terms of what our thought processes are in this case. I have, or rather I would say that we have a fairly good balance here in terms of Dr. Natarajan as a physics professor, Dr. Mukund as someone very, very dedicated to computational thinking and mathematics, and my own background of whatever work that has been done in terms of the linguistics side. I'm going to actually open the floor to and ask Dr. Natarajan to give his opening remarks, and then we will take it forward from there. But just to complete the thought process, we do want as many questions as possible so that we have a fair amount of time that we won't be talking, but we would be responding. Hopefully, we will have a lot of questions from the audience here. Yeah.
Thank you, Vish. Thank you, the organizers, for giving me this wonderful opportunity to share some of our thoughts with you all, very distinguished educationists. And it was an amazing experience. For the short period I was able to participate before lunch. So I could see the enthusiasm level on both sides. It was wonderful, and I'm very, very happy to be part of this. If you look at Education 2040, I have a completely different view. I don't know how many of you will accept that, But anyway, that is a way we are trying to move towards, as a matter of fact. So if you look at the 2040 education scenario as I imagine would be, most of the big institutions, at the higher level at least, universities level, they will be only examining organizations, because they may have large number of students off campus than on campus. This trend is increasing, especially after the recent corona, everybody got used to working at home, studying at home, not going to school, right? Whether it's good or bad. Anyway, so you find the access to education is now at a level which was never before thought of. If my student is not attending my class at IIT, I can only think that he is attending or listening to a lecture by an MIT professor, Walter Lewin or somebody in his room. Because he can have a choice. If he doesn't like mine, he can go and listen to a Yale professor or a MIT professor. So there are many people now, we all know, with so many virtual universities, including Google, coming into existence, which are charging very limited fees for most of the courses. There are enormous number of people who are not anymore going to a formal institution, and they are able to access an exceedingly wonderful level of content, and it is only self-learning. We all know learning is a lifelong process. It is not going to end at the end of a degree or a diploma. Especially at the school level, for example, you also have enormous amount of resources available in the web, in the internet, and so people can learn many things on their own. Apart from that, we all know, most of us from our early childhood learn many things by actually doing it. In many occasions also, if you want to learn music, nobody comes and teaches you in a classroom. If you want to learn swimming, you cannot learn swimming by reading books. And if you look at the history, Newton did not write JEE, did he? And he did not join Cambridge or Oxford to discover great gravity, right? So the whole process of learning is there right from at birth. They learn many things by looking at the parents, by maybe a little bit by going to the school. But we seem to have ignored that part of the students' ability to learn on their own. We always think that we have to teach them all the time. So my first point would be that our teaching should reduce by at least 50%. The rest of the 50% should be enabling the learners to learn on their own. We cannot make it 100%, we all know it. Especially if you look at early schools, you have to have certain formal levels of education. Engage them in a classroom atmosphere, make them do some exercises and things like that. But 50% of their time at least should be left to themselves to learn by maybe throwing few questions or few activities and things like that. And the level, the space at which they will be able to learn during those interactions, which is actually some kind of a peer level learning. Okay, that will be phenomenal. This I have experienced myself, because many of you know that I go to several schools and colleges to perform demonstrations. I want to bring the Newton's experience into the classroom. So I will perform an experiment, and I will throw open the question to the students and invite them to give me wrong answers. Because we are always obsessed with right and wrong, right? So in science, it doesn't matter. You have to come out with a convincing answer without worrying whether it could be right or wrong. And then we later discuss about it and try to formulate the right way of interpreting the result of an experiment. So that has to be instilled right from the early childhood. That we see many of the international arena. You know, you go to US, for example, many of our own grandchildren and all that, we are now in other countries, you know, they will be they were able to tell us that the school system is completely different. It encourages this kind of peer level learning on their own by performing activities, and that is one of the things I think we should perhaps look into. There are a lot of things. For example, there are many experiments. I don't know, many of you would know Sugata Mitra's experiment, the hole in the wall experiment. You know that. Sugata, when he was in IIT Delhi, he went to a nearby village and put a small computer there without any instructor around, with a keyboard and a mouse, and in about 10 days, you know, the children from the slums, they were able to understand computer, they were able to operate computer, the phenomenal level of learning. And not only that, the elder sister is pushing the shoulder of the younger boy, and that fellow is teaching the sister how to operate the computer. So you can see the peer level learning and throwing a challenge at them is one of the most important aspects which is missing. Our exam system, we all know how it is. Okay? If it is 7 plus 5 is equal to 12 will be taught in the class, and the teacher will ask in the exam what is 7 plus 12. If you ask what is 5 plus 13, out of syllabus. So they are not prepared for it. So they are not prepared for challenges at all. And we all know, I tell my students when I teach, I am only teaching what I know today. I do not know what I have to teach for you to be prepared for the future. Because when I am teaching 8-bit microprocessor, for example, in an electronics, when he passes out, it will be 16-bit or 32-bit processor. The technology would have so much evolved, and therefore he must be having the ability to learn on his own and prepare himself to face a completely challenging future when he goes out. So this has to be kept in mind, otherwise we will miss out the bus, not only to 2040, even beyond. Therefore, this is one of the first point I wanted to share with you. Maybe I will allow the other panel members to share their ideas. Thank you.
Dr. Mukund.
Yeah, so thank you. Like Dr. Natarajan, I think this is a great privilege to be here, and a huge opportunity to talk to all of you and share my thoughts and also listen to your feedback. Of course, I mean, I do interact at school level with some students, but my interaction is usually at university and higher levels. But obviously the products of schools are whom we see, and many of the concerns are across all these areas. So I think one thing that we definitely see, especially when you come to undergrad, is that students are very narrow in what they like and what they claim to like. And I think this is partly a problem of the proliferation of knowledge. You know, we have so much, so we cannot anymore aspire to be like Newton or other, famous scientists or Galileo or other, Gauss, who invent the science and mathematics that they are doing, right? So now you have to start with 300 years or 500 years of history of any subject to get, an incremental step forward. And there is, I think, a misguided notion that we all need to know all this, right? So I think we are just too obsessed in a way with teaching everything to everyone. And I think this is something we need to realize, that we are missing out on these connections between the subjects in our effort to go deep into every subject and tell everybody everything about everything. So in this process, people don't understand that, for example, traditionally, subjects which I am more familiar with, mathematics and physics, grew together. I mean, mathematics was used to explain physics, and then physics derives some new principles from the mathematics that comes out, and it's a mutually symbiotic thing. So, somebody discovers non-Euclidean geometry and Einstein uses it to model space-time, right? So it goes both ways. And this kind of synergy between areas, you just don't get to appreciate. So I would just like to quote out of context. So if you have not seen this, I would like you to go to YouTube and find on TEDx this wonderful TEDx talk by Chimamanda Adichie, a Nigerian author. It's called The Danger of a Single Story. right? And now this is completely out of context because she's not talking about this at all. She's talking about single story in the context of social things, oh, you are from Africa, you must be poor, right? We all have a unidimensional viewpoint on everything, and teachers and students are no more than that. Oh, I hate chemistry, I hate history. This is not geography, that is not biology, right? So we all have this single point of what we think the subject is and what the subject is not. And I think we need to move away from that. And just as a closing thing, before we proceed, for example, one of the biggest innovations which has come out in the last maybe 2 decades is that biology or life sciences is very much a mathematical and computational science. But where will you find a 20-year-old who knows biology and maths? Nowhere. Right? So who is going to push this subject forward if we have systematically trained people from school level to think of these as two polar opposites? And forget about humanities and computing. I mean, the whole business about designing accessible interfaces to our devices. All of these things require a multi-dimensional understanding of subjects and topics, and we just, I think, are losing the plot on that, and I think that's what we need to address.
Thank you. I think in addressing the fundamental idea of what will endure, you brought the question of learning to learn as the biggest skill that one can possibly deliver. And when we also talk about the idea of multidisciplinary predisposition, I use the word predisposition very carefully because of the fact that I think very consciously and with good intent, we ensure that that predisposition does not happen as an outcome of schooling. We have the subject compartmentalization for a certain convenience of delivery of learning, but we have made those walls so tight, we have made those boundaries so rigid that it is very, very difficult to find educators or school teachers who are actually multidisciplinary. Specifically, I would like to actually see whether I can provoke your thinking in the direction of something that we call academic literacy. This is not a term that is widely used. It is something that I think at some point of time in our discussions internally, we coined this term academic literacy because we found that from a language perspective, I consciously engage with functional language. I consciously engage with literary language, which means that I move from that functional, I will teach poems, I will teach ballads, I will teach Shakespeare, I will take it forward. But at no point of time do I consciously say, how do I move from my linguistic ability to solving a word problem in mathematics? That is left largely to accident, whereas that is actually a capacity that can be nurtured. And I am probably one of the most fortunate people to be born in a home where in 400 square feet and 6 of us at home, we had so many things happening that every time that you went to bed with your 4 siblings and your parents, and somebody would just start saying that 3. The next person will use his or her own imagination and say 6. The third person would use his or her own imagination, but each of them is doing an algebraic equation here and come up with 11. Now the number of possible equations are reducing. So by necessity, at some point of time, all these 3 or 4 or 5 people who are playing this game would work with only one equation because you have to discover which is the equation that is actually relating 3 to 6 to 11, and then you will soon find. Now, when we talk about can a 2-year-old or a 3-year-old deal with algebra, by all means you can deal with algebra. But that is the nature of, let us say, nurturing that happens. And there was never, as the family was full of musicians, so music was a big part of your growing up. School was a big part. If there are exams, there is no cutting the music class because the fact that exams will take care of themselves, music and art has to go on. So there was never a kind of a hierarchy of disciplines. I'd like to actually do a little bit of a exercise with some of you. Can we have the slide? Okay, at some point of time earlier, I had done this thing called Raising Learners for Galactic Citizen 2040. Yeah, but let's start on Earth to begin with. How many of you get this slide? From the previous slide to this one, how many of you could get the humor in it or the joke in it? Because to get the humor in it, you have to actually be multidisciplinary to begin with. I mean, 9.8 meters per second squared for, who would recall what is it? The acceleration due to gravity, right? And so we are on Earth because Earth has its own figure. Every planetary space would have its own figure. And then, you know, this is a problem that I have actually dealt with, and some of you may be familiar with it if you have been part of my workshop. So this is a problem that I pose in every English language workshop. 44% of the mangoes in a basket are bad. And you ask the next question, which is the third standard question. Go ahead. What is the fraction of good mangoes? Now we don't have the time to wait for your answers because very often I've had to wait very long for this answer. But the phenomenon that I want to share with you is the fact that approximately 70% of the room of educators will not even attempt it. Not because it is difficult or they can't think about it, but somewhere or the other, there is this artificial thing which says that I am an English teacher, maths is not my subject. And so even at a third standard level, the attempt at this question will not be there. And then you go on to ask, after the answer has been given, you can all figure out the answer in your heads if you can. What is the ratio of good mangoes to bad mangoes? The average response that I get, the average amount of attempts that I get would be about 20% of the audience. The average number of correct answers that I would get would be 3 to 5% of the audience. This is not a matter of amusement, it is a matter of great, let us say, concern, saying that if this is where I am as an educator, how am I going to actually create a multidisciplinary space in my classroom? I'm taking off from there. And then you go to a 7th standard question. And I will almost, in 90%, sorry, not in 90, that's unfair. In 50% of the cases, I will not get the right answer. And I'm talking about groups of 50 to 100, principals and vice principals, senior educators. So this tells us this to a certain extent, points in the direction of the fact that this, how the multidisciplinary bias that we create actually is already very strongly ingrained within us. So how does one actually negotiate this as a problem? I want to do a little exercise with all of you. I want all of you to close your eyes. I want all of you to close your eyes, please. I am going to read out each of the sentences that you have already seen, and I am going to ask you to visualize it as clearly as possible. Ramu has 23 mangoes. Rani has 12 mangoes. I want you to visualize each of these. How many mangoes do they have in all? I want you to visualize this. Please open your eyes. Were you all able to visualize the 3? Yes or no? I'd like an answer. Yes or no? Were you able to visualize it? Think again. Were you able to visualize all 3? Yes or no? Did you visualize the answer to the question or did you visualize the question? You visualize the answer. The question is impossible to visualize. No, because you're always going to be seeing both of them with 12 mangoes and 23 mangoes. So that is the answer. But the thing is, I don't even understand from a language perspective, I have not even thought about the fact that when I present this problem to a first standard child, I am asking a question which is beyond the comprehension level of that child. It is simply only a very small percentage of children would actually understand it from the English of it. They will answer the question on the basis of the fact that you said in all, total, add karo, remaining, left, you subtract. So from a language perspective, when I have not enabled this child to actually think of the problem, where am I going with the problem itself, and why do I have such a big gap between numeric problem correctness and word problem correctness? A lot of it has to do with language. If you look at your 4th standard textbook, and you look at the English language textbook, and you look at the science textbook, and you tell me whether the standard of English in the English language textbook comes anywhere close to the kind of language engagement that you're expecting out of your student in science. The idea of how many mangoes do they have in all comes into the realm of what we can call an abstract level or an intangible idea, which requires a much higher degree of language processing ability than the first 2 sentences required, or even the answer, Ramu and Rani together have 35 mangoes, that is also imaginable. But the question is not visualizable. This fundamental recognition of the fact that this is where the gap from functional literacy to academic literacy actually has to take place. And if we do not address academic literacy in some form or the other, you will continuously find language as a barrier to actually entering the domains of science. So each of these, I'd just like you to read it silently to yourself, and I'd like you to visualize these little paragraph that's there in front of you. If you want, let me have you close your eyes. Let's do this exercise. Please close your eyes. Don't read it. Please close your eyes. Imagine a glowing candle in front of you. The candle is tall and sits atop an ancient brass candle holder. The wick of the candle is ablaze with a long quivering flame that dances playfully. You peer at the teardrop-shaped flame, enchanted by the shades of color. The tip of the flame is light yellow, shedding a golden glow around it. The middle of the flame is bright orange, the color of the sky lit by a setting sun. The wick is burned black at the bottom, surrounded by a dazzling blue radiance. The heat of the flame melts the candle gradually, causing the molten wax to trickle down the sides. You stare at the soothing flame for a long time and slowly fall asleep. Please open your eyes. Did all of you enjoy the visual? What gave rise to that enjoyment is the way the writing is done, is the way that the visuals are triggered. All of us have seen a flame. All of us have experienced it. To what extent do we actually see it in detail? As we nurture this ability of visualizing text, we also nurture the ability of being able to understand language at a conceptual level, that if you have the statement of Newton's first law put in front of you, you will see the pictures around Newton's first law. You will not just memorize it, but you will actually understand it and take it beyond that point. Similarly, you have these other ideas. Each and every one of them, if I nurture the inner vocalization and visualization through language, I have the opportunity to actually understand the statements and understand the explanations around it instead of just doing problems around it. Each of these can be visualized if I have nurtured academic literacy, and that is the bottom line that we want to talk about. I think I have taken a little too much time. I'll end here, but I wanted to give you this sense of what academic literacy could possibly be and what is that element which is critical from a standpoint of learning to learn. So I'll actually throw a question back to both of you and see whether are you able to, in some form or the other, relate to this idea of language as one of the entry barriers towards the sciences and mathematics.
Yeah, very
Yeah.
true.
Yeah.
I fully agree with whatever you said, but that is a reason I believe if you make, in science it is slightly easier,
Yeah.
because instead of saying the properties of carbon dioxide, for example, if I make a student prepare carbon dioxide and ask him to extinguish a candle, you know, that experience gives him
Yeah.
beyond all languages. He will be able to understand the concept. It is true of everything. I mean, a lot of topic concepts in science should be taught in that mode.
Yeah.
Okay. So that makes them, all their senses will be acceptable, receptive, and then they will be able to understand the concept that is happening. So they don't have to again take out a book and read about this. Okay. So this is one of the main concepts I have been advocating for a long number of years. And people know that, for example, I will give a typical example. In some of the schools, I started an innovation lab. When the principal was ready to start, I said few important points. 1, no examination. 2, pure fun. 3, completely hands-on. 4, teachers can come and participate, but they have a very important role. They should not compare, they should not interfere and all that, but they should keep on saying, amazing, how wonderful it is. How did you do it? Something like that. That's all they have to do. And then you find, and at the end of the exercise, the student has to write a small paragraph about his or her experience. It was an amazing experience. We used to put it on the notice board. Some of you are interested may see some of those things available even now in the schools. So this is beyond all languages. You can use it Tamil if that fellow is familiar with Tamil or English or whatever it is. So that perhaps is one other way where you engage them in something with the hands-on along with the peer. So this entire exercise, for example, in this case, was done with 2 students involved in one activity. And then it is only 1 class per week for each class. 6, 7, 8, I have no age barrier. Age barrier I don't have. You want me to bring a LKG student, we can excite them with a lot of activities. We all know as teachers, as parents, we know how to excite them, what engages them most. Okay, we can always do that. But that is very important, and that will enormously improve their skill. So they need not know, as he was mentioning, you know, the compartmentalization is very artificial. Physics, chemistry, biology, etc. So when you take them to a forest or to a zoo, or so many things they learn, which is beyond their curriculum. Okay, I am also not advocate of a curriculum, so I don't believe in curriculum, as a matter of fact. Because if I give it to a 10-year-old guy my cell phone, he will come and teach me what I don't know in maybe a couple of hours. So their ability to learn is so enormous. Are we giving enough food for them to digest things on their own? It is not filling a bucket. Teaching is not filling a bucket. It is lighting a lamp. So they must be able to experience and then learn from that. And that is completely missing. We have a standard laboratory program. We all know that. Where there is a set procedure, they have to follow that. If they don't follow, they will not get mark. You know that. Okay, so that kind of thing should be broken, and that barrier should go, and the children should be able to. That is that 50% that I am talking about, irrespective of the level, whether it is a very earlier schooling or later even in college. You know, PhD is something like that. They try to do things and they discuss with their guide and they keep on doing. That is the only way creativity can be nurtured, and you will be amazed how the fellows are coming out with phenomenal suggestions and questions. You know, that I think is the most important critical component, which is basically missing in most of our educational system, including in the school level.
Your perspective.
So to go back to your question about language, so I definitely see a kind of a gap in communication skills, And this is particularly, so I want to actually talk about something which is, so the examples that you gave, I think they're very critical. As you said, these are things that we have seen or we know how to see. And then when it's written or expressed in language, we visualize what we have seen.
Yeah.
So I ask you to imagine a red square, and you can imagine a red square. I ask you to imagine a blue cube, and you can imagine a blue cube. Now I ask you to imagine a purple 4-dimensional cube, and you're stuck. Right? And this is the problem which happens a lot in abstract mathematics and to an extent in computing also, which is you're dealing with a level of, you have taken familiar procedures, notions, so numbers come out of counting. You see five balls, you see 5 stones, you see 5 this, and you get the number 5. So when you see 5, you think of 5 something, 5 dots, 5 something, right? Then, but when you go to higher mathematics, as I said, you go to these kind of higher dimensional geometric objects, or you talk about the fact that a teacup is essentially the same as a medu vada because it has something with one hole in it, right? Now to understand that and to explain it to somebody else requires a level of communication, and especially to somebody else who is not aware of these concepts to begin with. And definitely, I think some training or some practice in communication is needed to convey this. So a few of us used to ask, Professor Seshadri, who started CMI and who was famously incoherent as a conversationalist, right? And but used to do the most amazingly abstract mathematics. And you asked him, how do you work on this? He says, I see them. Right? So he had a picture in his mind of what he was working on. And he could manipulate these pictures in his mind and translate them into symbols on paper. And that ability to tell somebody else what your symbols mean in a way that they can understand, I think is essential. Otherwise, you can be doing whatever you want and nobody will understand what you're saying, and there will be no progress. So communication is essential. And whether it is language in the conventional sense or it is language in a imaginary world, if you want to think of it that way, it's essential. And I think this skill, unfortunately, I think is not taught.
Nurtured, consciously. Yeah. And I think I'm just taking off from your point in terms of, suppose we look at, even at an MSc mathematics level, I'm not talking about CMI standard, I'm talking about, so many other areas. When you take, let us say, something like calculus, I know how to do a lot of, let's say, magic tricks using calculus, but I may not have understood the fundamental idea of why I'm doing what I'm doing, how I'm doing. Would you agree that this, you brought up the idea of abstract ideas, because see, there are obviously ideas that are tangible and there are ideas that are beyond that ability to visualize. And that is where, unfortunately or fortunately, you are forced to rely on language as your primary communicator, especially in higher order thinking. More and more the criticality of it actually re-emerges at a certain stage. Would you comment on that?
I will take it a little bit. See, this brings in a very important aspect of education, whether it is science or whatever. Now it has been formatted in a way, it can be given in a formal setup in a classroom with an examination-oriented approach and things like that. Whereas if you, for example, take how Newton, Leibniz, they built this calculus system, what prompted them to think in these lines, and why they have to invent it, for example. So if you go into that history of mathematics, which is not at all taught. So if you go, how, for example, when you think of Einstein, for example, he used to ask, how will it be when I travel with a beam of light? How will it look like? So that kind of inquiry, there is no room for that. It is all in a formal setup. You have lessons and you have questions. There are usually teachers also will give you the bracket, okay, between this and this for this first question, between second question, you mug up and then write. This is how most of the things are happening. So there is the concept of one question and one answer is also not very valid, You never meet such things in your life later. For every question you have multiple answers. You have to qualify which one is most appropriate for a given constraints or situations. So the history of science is a very important component which we completely miss out. If you wake up from the grave, Maxwell, he formulated the Maxwell's equations of electromagnetics.
Yeah.
None of them looked like the way he prepared originally.
Yeah.
Over the years, they have transformed
Yeah.
and then brought into a very succinct form in the form of 4 equations.
Yeah.
So if you ask, can you identify these great equations? You will say, no, I have never seen in my life. You get my point?
Yeah, yeah.
So it has to, that component is completely missing. If you go there, how he got that idea? Why did he invent this? Steam engine, for example. Then you find it is such a simple thing, and it is an evolution from there onwards, where many more minds pour into it. They add delta X at every stage to develop it, and therefore the fellow gets a confidence that maybe he can also start something like that and develop it further, and that way we may be able to generate more number of scientists.
I think you've made a very strong point in terms of science becomes a story.
Yes.
And the story is far more engaging than if I were to teach it purely as theory.
Yes.
But I actually don't want to miss out on the idea around computational thinking that also is one of those extremely critical and enduring kind of skills that we should look at, because a lot of work that's happening is largely in teaching children to code rather than using coding as a means to nurture a certain skill. So I'd actually like you have done some work in that area. So
Yeah, that's right. So, so we have been working, so nationally there is a movement called CS Pathshala, which has been looking at computational thinking in schools in particular. Now, computational thinking is one of these kind of umbrella terms, as you said, which covers a lot of things, and for most people it is related to teaching school children how to program, how to write code.
Yeah.
But actually, you can start with a lot of non-coding examples, activity-based things. It's more about organizing your thought processes to solve problems. So I mean, it's very hard to even define what computational computing is about, right? So computing is essentially, it's a way of solving problems, but there are many constraints which you don't bring into normal problem solving, which you have to address. First of all, it has to be effective. I have to be able to tell you how I solved it. Right? I can't just say there exists a number which does something. You have to tell me how to find that number. And the second thing is you have to do it in a reasonable amount of time. So there are resources, there is time, there is space. So you have to do it effectively and in a kind of translatable manner. So I can take this solution and apply it on others. There has to be a system behind it. So all of these things go into computational thinking, and I think that we are, I mean, very much like mathematics has become an accepted part of our curriculum because it underlies so many things. Unfortunately, maybe we'll come to it, the way it is going in schools, it is becoming inaccessible very fast to most students. That's a different question, but the fact that nobody disputes that mathematics should be taught, right? Now the question is, should this be taught? Should this kind of systematic thinking be taught? And I personally feel that it is an essential skill. For one thing, we have to do more and more of this in our daily lives, right? Right from doing silly things like organizing the information on our cell phone, right? To the fact that we are dealing with clutter and everything that we do. And if we are not systematic about addressing life around us, we will not be able to deal with the complexity of things that we have to deal with. But secondly, I think it is a skill which translates into many domains. I think a lot of learning is very fact-oriented, especially in school level. As I said, at its heart right now, biology is a mathematical science, but you would not, of course, expect any school child to appreciate that, because at school level, biology is traditionally seen as a lot of facts to memorize, a lot of strange sounding Latin names, and a lot of peculiarities about different things. And similarly, history is a bunch of unconnected facts, geography is a bunch of unconnected facts. But if you try to put some reasoning, why did this person invade that thing? What was happening at the same time on the other side of the border? We never see that, right? You're doing history of, maybe you're doing Indian history today, and tomorrow you're doing European history, and day after you're doing something else. And you don't ever draw connections, you don't ever draw, and if you one can try to make these connections and systematic things more explicit. Of course, it's easiest to do in terms of data and things like that. You can collect data, you can analyze it, which itself is so computational thinking is a very broad thing, but I think that it deserves a place at the forefront of
as you're speaking, I'm
organizing.
thinking about a thought came into mind. Should computational thinking actually precede the teaching of mathematics?
So, if you think about it, the mathematics that we teach in school is actually computation, right? We teach them how to do long division, how to do square roots, how to do this, how to do that. Has anybody in this room or anybody who at school level ever taught their student why that procedure actually computes the square root?
Yeah.
We never do that, right? We just say if you follow these steps, you will get the square root. So the mathematics is actually missing, right? It's only the algorithm or the procedure that we are teaching. And so in a sense, we are doing disservice to both sides because we are not telling them it's only a procedure or why this procedure is better than that procedure. So we are not teaching them the algorithm, nor are we teaching them the mathematics side of it. Of course, now something has to give. I mean, you can't teach all of this and teach what you're teaching now. So that's the other big quandary that
I think one of the points that you mentioned was everybody need not, I think the size of the syllabus itself
so that is
has
the biggest,
become so huge that not everything is really essential in terms of, moving forward in one direction or the other.
And the teachers become obsessed with covering the syllabus
Covering the
when they are supposed to uncover it.
Yeah. I think that's it.
Yeah, but I think that's also, I mean, one of, this I see at all levels, including at the university level. I think the problem is the other side of the syllabus is the exam, right? And so long as we are driven to teach towards an exam, we have constraints about what we can teach or how we can teach it. Even more so if the person who is setting the exam is not the person who's teaching the material. Because how can that person know how I taught the material? So unless the teacher has the freedom to assess, it's very hard to teach towards an assessment which somebody else is going to teach. And coming from the other side, if you are going to assess a class without knowing what the teacher has done, you can only look at the syllabus. And it's your interpretation of the syllabus, and then you don't interpret. So I've had this, I mean, this was an early and very difficult experience for me soon after I became a faculty member. I was asked to set an exam for a university somewhere in Tamil Nadu. And I had no idea what to expect of the student. So what do? I look at the previous 3 years question papers and I try to reproduce similar questions. And that is unfortunately the system that perpetuates. Right? The
That is what they want you to do.
Yeah, but I'm saying that there's no escape from this system the way it is set up. And the other thing is this business about cramming the syllabus with, or the subject material with facts is because it's easy to ask questions about facts. Right? I can ask you, do you remember that? Do you remember this? Do you remember that? You not remember that. So you know 3 out of 4 things. If I ask you how to do this and you try to explain and I have to decide whether you are halfway there or 50% or 60% or you've not got the idea at all, that's much harder to evaluate.
Yeah.
So in a way, it's also, the difficulty of doing meaningful assessment is also coming in the way of changing the way we teach. We can't teach things which we cannot set trivial exams for.
But I, taking off on that, when we talk specifically, because we are talking about the algorithm of learning in a sense, what it requires is courage, right?
Yes.
Because no learning is going to be a failure, and so this obsession to assess. And I think before we go to the next point, I actually want to trigger. Can we trigger the Mentimeter question on multidisciplinary learning, because you talked about computational thinking and history. So
I will add one more point before we
while
go
they
to that.
do it,
And that is on the evaluation.
Yeah.
Okay, that is an obsession every teacher has to be continuously worried about.
Yeah.
But with the system, for example, when a PhD student comes for an admission to IIT, when we ask a question, that fellow is, sir, you want me to get me answer on my own? Why don't you give me A, B, C, D, 4 choices?
Yeah.
I will tell you which one is right.
Yeah.
So we have programmed that from the LKG. So the whole idea of knowledge is lost. The idea is acquiring skill to write an exam.
Yeah.
That is how we are getting. You can see the quality of students we used to get in those days when there were subjective examination, when the numbers were limited, to now when it is in lakhs. And because of the logistics, you have to follow such kind of machine evaluation, right?
Yeah.
The whole, idea is completely lost. Not only that, at the end of 4 years, we all know, it is true of many of us, we never use what we learn in our colleges throughout our life. Almost 90% of us, we don't go into that area. You go to management, you go to something else, and you end up somewhere else. And therefore, the whole thing looks as if it is meaningless. It is not. There are a lot of other skills that we learn in the process. But still, why should we attach so much importance to such examinations, which ultimately he is answering right or wrong, he is not going to decide his future most of the time, right? And so this is a very important question that perhaps we should look at.
Yeah.
Please.
No, so the question is there, and I think we have the answers in front of us. I think we have politically correct answer here coming through.
No.
Because eventually, when we answer that as a yes, we would need to kind of have the courage to actually implement it.
It is practical, I can tell you, in the sense that, of course, it is not going to happen tomorrow. It requires enormous amount of cajoling, all the teachers and all that it is possible. Immediate response itself is it possible? 60/40, right?
Yeah.
So, we have to transform our classrooms that way. It should not, see, if you don't teach, you think they cannot learn all those subjects?
Yeah.
Is it
no,
true?
but that is the assumption. No? We presume that
we have to get out of that obsession. And so you find that they are able to learn many things on their own, peer level. So what I am saying is, have 50% of your normal classrooms as such. Another 50% you go there every week, once or twice, pose questions to them and start a discussion. Give them a simple problem, ask them to solve, help them, mentor them. Initially it is difficult. Over a period of time you would find amazing results. So that is what I am trying to say. I am not saying completely discovery based. I am not saying. Throw them challenge. Even at the LKG level this can be done. Many things. If you go to many international schools, these are all happening already. Okay, the Montessori levels and things like that. There are enormous amount of research. There are enormous amount of activities which are already existing. So it is certainly possible. Okay.
So we'll have actually questions from the audience.
Yeah.
Good afternoon, everybody. Good afternoon, sir. I really want to stress on that academic literacy, sir, because my research was on content and language integrated learning, and it's sprung from the experience of teaching both physics and English. So I used to find in my class, children enjoyed physics the moment they understood the English behind it. So that was the starting point, and that was the starting point where I started doing my research, and I submitted my thesis on that. And as correctly said, there are two aspects to the language. One is BICS, we call it, basic interpersonal communication skills. The second part is cognitive academic language proficiency. It is called CALP. Very conveniently in our classrooms, we ignore CALP. Cognitive academic language proficiency is never taught or made possible in the classroom. Research says it takes 2 years for the child to learn the language, for example, English. But it takes 7 years to learn academic language. So that part of language gap that is happening in the classrooms is the basic reason why science and mathematics learning becomes so difficult. After my experimental studies, I had children coming back and telling me, I taught physics through English. It's called content and language integrated learning. You have to have a language class in a content class. So first it will be content teaching, then language teaching, where you teach the terminologies of the subject. So then we have the cognition aspect, higher order thinking skills. Very conveniently, we ignore teaching higher order thinking skills in the classroom, and we expect them to do it in our question papers. Strictly speaking, they have to be trained to do higher order thinking skills. The last part of that lesson planning will be culture, where culture is brought into the aspect of lesson planning. So once all the 4 aspects are taken care, rest assured, mathematics and physics, I think it is just a joyful journey for the child to learn. I would like to just conclude. I think we should all as educators pay attention to this aspect of language learning and that visualization that happens. in order to make it. I had children coming back and tell me, can you teach us social science like this?
Yeah.
Because there is word like arbitrary. Is this rule arbitrary? He does not even understand what it is. We go and drop terminologies in the class. Momentum. If you tell in English, it is mass. The project is gaining momentum. Yeah. Momentum is mass into velocity. Rest assured, he has not forgotten momentum, mass into velocity, because he knows project is gaining momentum is mass into velocity. There is some velocity involved. So we can make it joyful. And I thank everybody for giving this opportunity. And I think, can we do something to make language in the textbooks easy for children? Thank you so much.
Thank you very much for insights.
So there are two observations. One is, see, what determines language? See, when we are valuing the spoken language or the expression of language in letters, are we giving the pride of place to the language as we understand language from text? There's certainly a scope for finding non-verbal expression, say, other forms of communication that we have not even attempted. Yeah. So, see, you tell a story, and even with gibberish, I can figure out what the story is. Yeah. So, contextualizing, see, what we say in terms of associative information from the language, should it always be limited to, see, how it has been expressed? So another colleague here expressed that a significant load needs to be placed for English. So why so? I'm just curious to understand if there are other forms of communication which will qualify themselves as language in the space of training the children to understand better.
So in the morning, there was one slide which said that text is only 7% or 15% of communication, right? And Dr. Mukund also used the word communication in the sense of encompassing everything. So let me give you a simple example of non-verbal communication within the verbal, right? If I have Newton's first law of motion in front of me, how I express it and how I say it makes a huge difference in terms of how I am able to understand or visualize it. So if I do not say an object remains in its state of rest or of uniform motion unless acted upon by an external imbalanced force. If I do not articulate it in a particular way, this is all non-verbal actually. The words are there, but then I am actually knowing how to stress, pause, comma. How many of our maths teachers or science teachers would actually, even state a theorem or state a postulate in such a manner that I can actually build a visual out of it? So you're right about the fact that the non-verbal elements are actually, it's a kind of a holistic thing, right? You are not communicating only with words. You are communicating with words. Even if I'm reading something, I must be able to read it with expression in my head. So which means that the inner vocalization has to be of a certain quality. If I'm reading a science textbook, I need a certain kind of vocalization to be happening. So your point is absolutely right, but it is possible. What one is saying is that we have not paid attention to it, as she has said. The moment we start paying attention to it as an important element of my learning to learn, because that becomes important. Even if I read, there are 3 children who will be able to understand the text at a broad level, but one child is learning much deeper than another child. What is that element of, that learning efficacy that I am building into it? And yeah, so we'll have.
I would like to actually share something, and
please.
It's beautiful. Like, unless the word is in my vocabulary, it is nothing but a symbol to me.
Yeah.
It does not mean anything at all. So what we actually do in our school, because mostly I deal with children with special needs, and language is the biggest barrier to these children. So what we do is the teacher gives the definition of words in focus. So those are the words involved in acquiring a particular concept. So once the word definition is given on the board, teacher explains it, and then the children dramatize it. Okay. Once they have dramatized it, we give them clay. And then children create a model of the definition according to their understanding. So once they have got all the pieces of that definition in their model, each child explains his model. So each child has his own unique model to represent the definition. So it is the teacher is able to also check out the perception of the child, whether there is accuracy in the perception of the meaning. And once that happens, actually there is mastery rather than memory.
Very nice.
Thank you.
So we will have a final Mentimeter if we have the time for it, which is on assessment, because we spoke about assessment. Okay, we have started getting answers for this. Oh, we'll keep it on since people want to answer this question. So while you are continuing to vote on this, thank you all. My gratitude to both of you for having been here with us and shared your insights. I think the algorithm of learning needs to discover what are those durable qualities and skills that will outlast whatever changes that happen in the outside world. And I hope that this has been an enlightening panel for all of you. Thank you all for your questions. Thank you very much.